Hello and welcome to Science Research Weekly, Season 4, Episode 19, Strange Patterns in Science. Get ready for cardiovascular aging via gut bacteria metabolites, the darkening of the global ocean, horizontal gene transfer in eukaryotes, long period radio transients, now with X-rays included, the R Journal Volume 16-2, and an industry University Cooperative Research Center's program from the NSF. This episode covers materials from May 23rd to May 29th. My wife and I welcomed our newest baby into the world, so I was off the grid for the last couple weeks, but I'm back giving you the weekly science you crave. Let's get started with some research articles. First up is gut microbiota-dependent increase in phenylacetic acid induces epithelial cell senescence during aging. Research found that bacterial metabolites from gut bacteria was elevated in aging humans and mice. These metabolites, so phenylacetic acid, PAA, and phenylactylglutamine, I think it's PAGLN. So these metabolites induced endothelial cell senescence, one of the drivers of cardiovascular aging. So therefore, reducing those metabolite levels could be a therapeutic intervention to reduce cardiovascular aging. Next up, the darkening of the global ocean. So measuring across the last 20 years, oceanographers have found a change in optical properties in ocean water. So a reduction in the amount of light being able to penetrate in deeper water. So that's the ocean, where the ocean darkening comes from. Now, this is important because the photic zone, so that's where light can penetrate, that's the most biologically productive and active zones in the ocean. And they found that around, I think, 21% of the ocean became darker. Though it is to be noted, about 11% became lighter. So I think if you're watching the video, you can see a bit of a map of that. The reason why, the authors suggest that there's been an increase in particulate matter and changing ocean circulation patterns, which actually in turn increases primary and secondary productivity. So there's more small things in the water, or increase in microscopic organisms in the water, bacteria and plankton, algae, which in turn reduces light penetration to the surface waters. So they make a big hubbub about this being a bad thing. But I feel that it's a little bit overblown if when the probable cause of it is actually increased ocean production of primary and secondary producers. Still very fascinating finding, and certainly does have impact on global oceans. Next up, speaking about impact, the article Impact Plasma Amplification of the Ancient Lunar Dynamo. So modern moon does not have a magnetic field, though it appears to have had one billions of years ago. So, but scientists have found magnetic rocks. They've been able to detect those on the lunar surface. And it's been too long ago since the magnetic field for that to be the source of it. So using simulations, scientists think that the current magnetism could have been generated by a lunar impact, so a large asteroid hitting the moon, generating a cloud of ionized particles, and essentially interacting with the weakening magnetic field in the past, and essentially impacting enough magnetism to account for the magnetic rocks we see today. Something along those lines. Speaking of lines, let's turn to our next article. Horizontal transmission of functionally diverse transposons is a major source of new introns. So transposable elements, aka jumping genes, can move around the genome of a eukaryote. But what about across species? Well, researchers studying a type of transposable element called introners, which can generate introns upon insertion, found evidence that they can actually move between species via horizontal gene transfer, possibly with the help of giant viruses. So they looked across a bunch of different genomes, and they found 8 instances where introners were transferred between unrelated species, so bona fide accounts of this happening. So very interesting there. And our final article of this section is detection of X-ray emission from a bright long-period radio transient. So there's a class of cosmological object called long-period radio transients, which probably are things like highly magnetized neutron stars, white dwarf pulsars, or white dwarf binary systems with low mass companions. At least that's what the authors say. Now, models predict that these type of objects, these LPTs, long period radio transients, should or could emit X-ray emissions, but no LPTs have been found that have emitted X-rays. However, there is now a candidate that has been shown to produce X-rays, both coincident radio and X-ray emissions. This is ASKAP J1832-0911. That is the object in great astronomical parlance. And so whatever this thing is, whatever this object is, it's very interesting, kind of challenging theoretical calculations. It might be something like an old magnetar or an ultra-magnetized white dwarf. It's really unclear at this point, but it does show that these LPTs can, like theory predicts, emit X-rays. Kind of a fascinating cosmological mystery that needs to be continually unpacked. All right, with that, let's turn to our research tools. Very exciting here. Volume 6.2 or 6-2 of the R Journal is now available with a plethora of research articles. Some interesting ones from my standpoint. Lucidus, an R package for implementing latent unknown clustering by integrating multiomics data. So that's Lucid with phenotypic traits. There's also an article, Current State and Prospects of R Packages for the Design of Experiments. There's BCC Long, an R package for Bayesian consensus clustering for multiple longitudinal features. There is PenCal, an R package for the dynamic prediction of survival with many longitudinal predictors, and Fuzzy SimRes, epistemic bootstrap, an efficient tool for statistical inference based on imprecise data. Use R 2025 conference has a virtual conference component that I believe is free to register for. So you can go to the link in the description of this video and podcast to see. Looks like some interesting talks here, like don't write code your users haven't asked for, sharing data science artifacts across teams using cranes, the future of asynchronous programming in R, including some virtual lightning talks like the wrong way to run code in R. So you can check that out. Over on R bloggers, there's a couple new posts that I think are of worth. First, from the Jumping Rivers blog, custom PowerPoint using Officer. So as stated, Officer package lets our users manipulate Word and PowerPoint documents. So in short, one can add images, tables, and text into documents from R. An additional document can be provided. Content styles and properties of the original document will then be available. So kind of interesting. And I think that the use case here is especially for people who are not using a Microsoft operating system, but they still want to be able to do stuff with PowerPoint. And then the second R blogger post is from Joseph Ricketts on R Works. It's the April 2025 top 40 new CRAN packages with entries like RGeo, providing tools to perform accurate species distribution modelings for rare species. There is DSCI-D, facilitates genomic and proteomic data analysis by providing tools for unbiased PubMed searching, protein interaction network visualization, and comprehensive data summarization. There is E2Tree, which implements the explainable ensemble tree approach proposed by a paper. And then finally, there is, of course, there's 40 of them, but I'm just picking the ones that stood out to me the most. The final one is Veyer, which implements position adjustment, visualize as you randomize principles for ggplot2. especially useful for applying experimental data. Then with CRAN packages, there's two new CRAN packages that might be of interest. There's Robin CID, Robust Inference in Complex Innovative Trial Design. There is MISR, classifying missing data as MCAR, MAR, and MNAR, which is missing completely at random, missing at random, or missing not at random. Closing out our time here with some research funding. First of all, there is a university or industry university cooperative research centers program from the NSF with a goal to catalyze breakthrough pre-competitive research by enabling close and sustained engagement between industry, innovators, and world-class academic teams and government agencies. And second, from Spark NS, there's a translational research program which invites PIs, principal investigators with promising discoveries in Parkinson's disease or autism to apply for the 2026 cohort. Tunickick-tastic, thanks for joining me for Science Research Weekly. Science on.